Welcome to this brief video tutorial demonstrating the deployment process of NeuVector in Google Cloud. This is Abdelrahman Mohamed, Global Solutions Architect for Google Alliance at SUSE, and I'm excited to guide you through this demonstration. NeuVector provides a powerful end-to-end container security platform that offers end-to-end vulnerability scanning and complete runtime protection for containers, pods, and hosts, including automated CI/CD vulnerability management and admission control, violation protection, threat detection, DLP and WAF sensors, runtime vulnerability scanning, compliance and auditing, endpoint and host security, multi-cluster management. It's 100% open source and fully supported by SUSE. The NeuVector solution contains 5 types of security containers. The first one is Enforcer, which is a lightweight container for enforcing security policies. It's deployed as daemon set on each node in the Kubernetes cluster. The second component is Controller, which manages the NeuVector Enforcer containers. A production environment requires highly available controller deployment configurations. Free controllers are the default in the Kubernetes production deployment. The third container is the Manager, which is a stateless container that provides a web UI for users to manage the NeuVector security solution. More than one manager container can be deployed as necessary. The fourth container is a Scanner, which is a container that performs vulnerability and compliance scanning for images. Typically, it's deployed as a replica set and can be scaled up to as many parallel scanners as desired to increase scanning performance. The last component that we have is the Updater, which is a container that, when run, updates the CVE database for NeuVector. NeuVector publishes new scanner images regularly to include the latest CVE for vulnerability scans. The updater redeploys all scanner pods by taking the deployment to 0 and scaling it back up, forcing a pull of an updated scanner image. The deployment of NeuVector can be accomplished through different methods. The first option is to use the SUSE NeuVector Prime web user interface, which uses a Helm chart to deploy NeuVector. Second option is to use the native Helm chart to deploy NeuVector on any Kubernetes distribution or Red Hat OpenShift. The third option will be using kubectl commands to install NeuVector on any Kubernetes distribution. The last option will be deploying NeuVector using Red Hat OpenShift operator. When it comes to deploying the NeuVector in a production environment, the flexibility is impressive. You have the option to deploy NeuVector containers on any certified Kubernetes distribution such as Google Kubernetes Engine GKE standard, Rancher Kubernetes Engine 2 RKE2, Amazon Elastic Kubernetes AKS, Azure Kubernetes Engine, Red Hat OpenShift, and more. To explore NeuVector subscription options via Google Cloud Marketplace, please reach out to your dedicated SUSE sales representative. They will provide valuable guidance on the process and ensure a seamless experience. Each type of NeuVector container serves a distinct purpose and may have specific performance or node selection requirements, which I will illustrate in this video. For today's demonstration, I will be using Helm to deploy NeuVector on Google Kubernetes Engine GKE standard cluster. Let's dive into the process step by step. Currently, my GKE cluster is up and running. Let's see some information about the cluster. I have created the workload pool 1 node pool for my existing container applications. Let's navigate to the node pool URL and gather some information. I have 3 nodes, as you can see here. I can observe the Kubernetes label for these nodes set as workload 1 equal yes. To enhance administration, monitoring, and troubleshooting, I will create an additional node pool, which will be dedicated for NeuVector Kubernetes objects. This segregation will not only streamline management, but also provide clarity between my current container workload and the NeuVector deployment. For efficiency, I have prepared the configuration for the NeuVector node pool. Let's take a moment to review it before proceeding with the creation of the dedicated node pool.
Here is the node pool name, NeuVector Pool 1. I enabled the GKE cluster autoscaler feature for dynamic scaling. At least I will have one node per each zone. GKE autoscaler will increase the number of nodes up to 2 nodes per zone when NeuVector needs more resources. So let's navigate here to the metadata tab.
And we see here the Kubernetes labels, NeuVector controller, NeuVector manager, NeuVector scanner, and NeuVector updater. In a few minutes, I will show you how these labels will be used in the Helm chart configurations to specify where the NeuVector Kubernetes objects will be created. Now, let's hit the Create button and pause the video until the node pool creation process is completed successfully.
The NeuVector node has been created successfully, as you can see. Here is the new node pool. Before diving into the Helm deployment, we need to set up a persistent volume claim for storing NeuVector controller data. This persistent volume claim should offer read-write many capabilities. Given that we are on GKE, I have taken advantage of the Google File Store service to host the NeuVector persistent volume claim. Let's go ahead and list the persistent volume claim from the command line to ensure everything is set up correctly before proceeding with the Helm deployment. Here is the command. As we can see, we have a persistent volume claim called NeuVector data, and it uses this persistent volume. Note that in order to ensure a well-organized deployment for NeuVector, I have created a new namespace named NeuVector to host the deployment and associated Kubernetes objects. To deploy NeuVector, I will be utilizing the Helm chart version 5.3.0. For a comprehensive list of available configurations, you can refer to the official repo that I will leave the URL for it in this video description. The next step involves adding the NeuVector Helm chart repo and updating it. Here is the command. Let's check the available Helm chart versions for NeuVector. Here is the command. I have decided to use Helm chart version 2.7.3, which is the latest one that we can see here. Before initiating the deployment, I have collected and organized all the necessary Helm configurations that I want to set into a single file. Let's check that file. Let's first clear the screen here. Here is the file. First thing, I will deploy NeuVector version 5.3.0, as we can see it here. I have 4 node selectors for the NeuVector controller, manager, updater, and scanner Kubernetes objects. Each node selector uses the corresponding Kubernetes label attached to the NeuVector node pool. We can see it here, this for NeuVector controller selector, and the one for manager, and the updater component, and finally the node selector for the scanner component. For the controller storage, I used the already created persistent volume claim, as we can see it here. Finally, I will export the NeuVector service over a load balancer to access NeuVector from my browser. We can see that here. Let's move forward with deploying NeuVector. I will clear the screen again. Before I execute this command, let's explain some parts. The first thing, I instructed Helm to create a new Helm chart from NeuVector called NeuVector. I used the NeuVector namespace. I instructed Helm to create a namespace if it's not there. I used the Helm chart version 2.7.3, and I bought the customized configuration that I have shown to you a few seconds ago using this file. Hit enter, and I will pause the video to allow the deployment process to unfold. Once it's successfully completed, we will resume and continue with the subsequent steps. As we can see, NeuVector deployment has been completed successfully. Let's perform a few checks to ensure everything is in order. First, list the Helm chart release status. As we can see here, the Helm chart release name is NeuVector. it uses the NeuVector namespace. Status is deployed. We use Helm chart version 2.7.3 and NeuVector version 5.3.0. The next step is to check the NeuVector Kubernetes object status. Here I'm going to get more information about NeuVector services, daemon sets, and deployments. As we can see here, the Enforcer daemon set has been deployed in 6 nodes, which we have in our GKE cluster. We have 3 controller pods deployed in the NeuVector pool. We have 1 manager, and we have 2 scanner pods. If I go up to the NeuVector Service Web UI, here is the external IP address that I can access NeuVector from. Now armed with the external IP address, let's log into the NeuVector Web UI. I will accept the self-signed certificate for the purpose of this demonstration. I will use the default login credentials. The first thing that I want to do is to enable autoscan, and then going to assets, nodes, and scan all nodes that I have in my GKE cluster. I will pause the video until NeuVector successfully scan all nodes that I have in my GKE cluster. As we can see here, NeuVector managed to scan all nodes that I have in my GKE cluster. If you have any further questions or need additional assistance, please feel free to reach out via email at google@suse.com. Thank you for your time and best of luck with your SUSE NeuVector deployment on Google Cloud.